Hello class, today we're going to do EOC review number 3. Okay, all right, I need you to make sure that you write these notes down and go back and study your notes so that you'll be fully prepared for your EOC that's coming up in less than a month, okay? Or really, we have about a month. The title of this page is going to be EOC, that's end of course review. EOC review, and this one's number 3. This is on systems of equations. Pause real quick. Systems of equations. Okay, so if you remember, a system is more than one. If we have a bus system, that's more than one bus. A school system is more than one school. So a system of equations is more than one equation. System or systems of equations is more than one equation. In this system, the variables x and y, or whichever variables you are using, have to have the same meaning in all of the equations, okay? The variables in all the equations, whether it's 2, 3, or 4 equations within the system, must have the same meanings. Meanings plural, okay? So if the x in the equations, if the x has a meaning of the number of hours, then the x in all of the equations have that same meaning, the number of hours. If the y in the equations is the total profit, then the y in all of the equations is the total profit. That's what I mean when I say have the same meanings, plural. Okay? All right, so now we've talked about what a system of equations, what they are, what a system of equations, what that is. Now we need to talk about what they look like, okay, and how to solve a system. So in this course, a system is not going to be more than 2 equations. We're only going to be dealing with 2 equations. So this is what that looks like. You can have 3 possible solutions to a system. There are 3 types of solutions to a system. So this is what a system looks like. You have, I'll draw it. Your X and Y axis, x-axis, y-axis, x-axis, y-axis. Draw one more. Okay. X-axis, y-axis. All right, so you could have 2, and we're going to do solutions. Let's do it for linear equations only. Okay, let's just do linear equations. Okay, so for linear equations, systems for linear equations only, you can have 2 straight lines that when you graph them, they cross each other. The point in which they share is going to be the solution. So a solution to a system is going to be the points that the equations share. Super important. the solution to a system of linear equations are the points that they share. Okay? All right, so if they cross each other at one point, this one point is the solution. Okay? So this has one solution. And that one solution is the one point that they share. So the solution here is going to be whatever that one point is that they share. Okay? This ordered pair is the solution. You may have two linear equations that when you graph them, they never touch each other. Again, the solution to a system of linear equations are the points that they share. They don't share any points because they don't cross. So this is a no solution. This is a no solution. Okay? Then you may have two linear equations that happen to be on the same or happen to graph the same exact line. That means they share all of the same points because by definition, a line continues without end. So this has an infinitely many number of solutions. So this is infinitely many. Infinitely many solutions. Because they share all of the same points, and by definition, a line is going to continue without end. So for a system of linear equations, the points could cross each other and share one point. The points could never cross each other at all. That's no solution. That means they're parallel. Or the lines could be right on top of each other. That means they share all of the same points. So that means that it's infinitely many solutions because they share all of the same points. And these lines are never going to end. So they have an infinite number of points. So that means they have an infinite number of solutions. Okay. All right. Ways to solve a system of linear equations. Ways to solve a system of linear equations. Okay. You could use the graphing method. One, graphing method. That means you just graph both equations to see where they cross, like we did up here. So all you're doing is you're going to graph both equations to see where they cross. Or if they cross at all. I'll say, so let's to see what points they share. To see what points they share. Okay? Number 2 is the substitution method. And your substitution method is going to be where you isolate one of the variables and you're going to substitute that expression into the other equation. Okay? So you isolate one of the variables and you're going to substitute that expression into the other equation. and substitute that expression into the other equation. So basically, you're going to use algebra or algebraic principles to solve this system. Okay. The last method that you're going to use is the elimination method. It's two elimination methods: elimination of addition and subtraction, or elimination and multiplication. So the third is the elimination method. Your elimination method is where you're going to use addition, subtraction, or multiplication to eliminate one of the variables and solve for the other variable. It's where you use addition, subtraction, and or multiplication to eliminate, and I am going to use the word eliminate inside the definition. Eliminate, that's to get rid of one of the variables to solve for the other. And then after that, you use substitution method to figure out the variable that you didn't solve for. Okay? All right, so those are the three methods. Those are the three methods. Okay? So with that very first method, the graphing method, okay, what you do, you might have y is equal to 3x plus 2. And then you might have 2x plus y is equal to 4. Okay, so in order to solve this system, you graph them both. But in order to graph the equations, they have to be written in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Okay, slope-intercept form. Y equals mx plus b. Okay, this is your slope-intercept form, where of course your m is the slope and your b is your y-intercept. All right, so you're going to label your m and your b so you can graph. This is m. M is attached to the x. I'm going to write it as a fraction, so I have rise over run when I graph. And my b is the number that has no variable attached to it. Okay. Now here, this is not written in slope-intercept form, so you have to isolate y so that it's written in slope-intercept form. So I'm going to move the 2x to the other side by subtracting 2x. When I subtract 2x here, I'm left with y is equal to, and I'm going to bring both of these down. I'm going to bring down my negative 2x first, and then plus 4. Okay. All right, so my m here, my slope is -2, and -2 over 1, sorry. And my b is going to be 4, okay? This is my slope, rise over run, and this is my y-intercept. So let's graph this first equation first. I'm going to find b on the y-axis. That's how I graph. So b is 2. Put my lines. Try to draw a good graph. Try to make the red lines equal distance away from each other. Okay, so we got b is 2. So you find 2 on the y-axis. This is my y-intercept. Okay, there we go. Now you're going to use your slope, rise over run to put other points on the line. So rise 3, that means you leave this point, you're starting a point and go up 1, 2, 3, and then you go over to the right 1. If I want points in the opposite direction, instead of going up 3, I go down 3. 1, 2, 3. Instead of going to the right 1, I go to the left 1. Okay? And I can continue doing this. 1, 2, 3, over 1. And this should form a straight line. It's better when you use graph paper. It's harder when you use notebook paper. Okay? All right, so let's look at this one. We have 4, positive 4 is our y-intercept. 1, 2, 3, 4. Okay, and we're going to go down 2 and to the right 1, down 1, 2 to the right 1, 1, 2 to the right 1, 1, 2 to the right 1, 1, 2 to the right 1. Okay, and you keep going until you run out of space. Okay. Now, they will more than likely give you a point that you can read. Okay. Whatever this X and Y point is going to be your solution. Okay. If it's hard to identify, you can go to your calculator and type in both equations, 2nd plus 7, 1, 2. Okay. And you can type in, make sure they're written in slope intercept form because it's not going to work if it's not. Got, oops, sorry. 3x plus 2. And then this one right here is negative 2x plus 4. Okay, so I type both equations in. Now I'm going to go to graph them. Okay, and see how that's about what I have here. Okay, so now to figure out where they cross, you can go to second, trace, and go down to where it says intersect. And now you're going to press enter. This is the first equation, second equation, and then it says guess. So just press enter 3 times, and it gives you the intersection. And see how it's not a whole number, it's a decimal. So my intersection or my ordered pair, my solution, where they cross, the only point that they share is going to be, and I'll write it over here, 0.4, comma, that's my X value, and 3.2. Okay, this is my solution. This is the one point that they share. That's this point right here. I could have squeezed it in right here, I guess. Okay. All right. So this is your graphing method. Your substitution method. Okay. Your substitution method is where you have 2 equations. You might have y is equal to 7. Let's do 7x. Let's do plus 1. And then you might have x plus 2y is equal to 3. So automatically, when you are doing the substitution method, automatically assume that they cross at some place until it's proven that they don't. Okay? And you'll know that as you're solving it, when you plug these values in and the variables cancel out, then that means it's not either going to be infinitely many or no solution, but there's not going to be one point that they share if the variables cancel out. All right, so one of the variables is already isolated. So we're going to take this expression and substitute it into the other equation. Okay, so we have x plus 2 times this expression, 7x plus 1 is equal to 3. So now the variable that we can solve for is x, okay? Because that's the only variable that's present here. So we have x plus 2 times 7x, which is a positive 14x, 2 times 1, which is plus 2, is equal to 3. All right. So now we combine like terms. We got 1x plus 14x, which gives us 15x. Then we got plus 2 is equal to 3. We're going to subtract 2 on both sides. So this is gone. This leaves us with 15x. This leaves us with 1. So we're going to divide by 15 on both sides. So this gives me x is equal to 1 over 15. Okay? So now we need to figure out what y is. I'm going to use the easiest equation out of the two. Go back to the original equations. You either use this one or this one to substitute the x value in to figure out what y is. I'm going to use the easier one. Okay? So now I'm going to replace x with 1/15. So that's 7 times 1 over 15 plus 1. So this is going to give me, when I multiply straight across here, this gives me 7 over 15 plus 1. Okay? So when I add, if I'm not using my calculator, I need a common denominator. So I'm going to change 1 to 15 over 15 because 15 over 15 is equivalent to 1. Okay? So this is going to give me 15 on the bottom. And on the top, that's 15, 16, 17, 18, 19, 20, 21, 22. Use your fingers and your toes if you have to. Here, this is already reduced. If you want to check to make sure that it's reduced and you have access to your calculator or they say it's calculator active, you can type in 15 divided by 22. Go to math and press enter twice. And you'll see that it is reduced. 15 over, oh, dang. It's 22 over 15. That's reduced, sorry. And you can leave it as an improper fraction or you can change it to a decimal. Look at your answer choices and just choose the best answer. I typed it in wrong. It was supposed to be 22 divided by 15. Sorry about that. And it's still reduced, okay? All right, so now you have your elimination method. Your elimination method looks like this. Your elimination method goes just like this. It is, you might have two equations. Let's do 3x plus 4y. Let's make that equal to 8. And then let's do x minus 2y. Make that equal to 2. Okay? So when you see two linear equations that look like this, the best method to use is elimination. Okay, so when you are choosing to use elimination, you look to see, can you add or subtract the x's or the y's to eliminate either the x or either the y. So let's look at this right here. This is automatically a 1 as a coefficient in front of the x if you don't see one. If I add, it doesn't eliminate the x's, and if I subtract it, it doesn't eliminate the x's. So let me look at this one now. If I add this, the y's don't eliminate, and if I subtract these two, they don't eliminate either. So now I'm going to use elimination and multiplication. How can I get these two to be the same? Well, in order to get them to be the same so that I can add or subtract to eliminate them, I would have to multiply this 1 times 3. And so then I would have 3x and 3x here. To eliminate these two, I would have to multiply this by 2. And so then this would make this a negative 4y, but I could still eliminate. So I have to choose which one is the easiest for me to eliminate. And I would prefer to multiply by 2 than to multiply by 3. So I'm going to multiply everything by 2. I'm going to choose 2 instead of 3. So the first equation I'm going to keep the same. And the second equation, I'm going to multiply 2 times times each of these terms so I can make an equivalent equation. I can't just multiply one side without multiplying the other side, then it's not equivalent anymore, okay? So here I say 2 times 1x is 2x. Then I say 2 times this negative 2y is negative 4y. Then I say 2 times this 2, which is 4. Now I can eliminate my y's. To eliminate my y's, all I have to do is add. So now I'm going to use adding to eliminate. So when I add this, this gives me 5x. When I add this, cancels out. When I add this, this gives me 12. 8, 9, 10, 11, 12. I'm going to divide both sides by 5. And this gives me x 12 divided by 5. Okay. All right. So now I am going to choose one of the other equations to solve for y. So now I know what x is. My x value is 12 over 5. Now I need to find my y value. And then I know that this is going to be my solution. This is the one point that both equations share. Okay? And again, always assume until proven otherwise that the solution is going to be 1 point. Okay? All right, so I'm going to choose the first original equation, x minus 2y is equal to 2, and plug in 12 over 5. So I have 12 over 5 minus 2y is equal to 2. Okay, so now I'm going to get y by itself by moving the 12 over 5 first. So I'm going to subtract 12 over 5 on both sides. Okay, so this is gone and I'm left with negative 2y. And on this side, I use my calc. I have 2, then I have minus, and in parentheses, I'm going to do my fraction, 12 over 5. Okay, and look at this. This is negative 0.4. So we got negative 0.4. Or you can write it as a fraction, which is math, enter. So you can do it as a fraction as well. But I'm going to go ahead and keep it as a decimal, okay? Unless my answer choices are fractions, then I can convert back to a fraction. I'm going to divide both sides by negative 2, okay? So this is going to give me y is equal to a negative divided by a negative, we know is a positive. So let's do this. We have a negative 0.4 divided by a negative 2. And that gives me a positive 0.2. So my answer, okay, is going to be, and let me go ahead and change this to a decimal. 12 divided by 5, that's 2.4. And my y value is 0.2. This is my solution. This is the one point that both equations share. This is part 1 video for systems of equations. Now I'm going to record part 2, okay? Please watch part 2 so that you can get the answers to the EOC review test questions, okay?